Hi, my name is Victor and you're with Revit Experiments. Yesterday in the evening I saw a message, a post on Facebook, one of those Revit related groups, about this. Hi, how to make this dome, basically. And it's an interesting geometry, and I was really pissed of some of the comments underneath that were saying, okay, this is actually really easy to make, you just throw in some adaptive components, or you need Dynamo, or don't make this in Revit. Revit is too for architecture, because all of these don't make any sense. I mean, it's a good question to ask, of course. So actually I dig this up a little bit, and first I'm going to show you what I have in Revit right now. So it looks like this. It is the character of that shape, which is really important, because anybody who says it's easy and it's adaptive components and curtain panels, they just overlooked it. They just took a quick glimpse at this and they said, oh yeah, it's just a divided surface or anything. But it's not, and this is actually a pavilion called Pact Pavilion, and the name is key here. Why is it called Pact? I'm going to get to that in a second. But when you want to create a shape in any program, in Revit or SketchUp, or doesn't really matter, you have to analyze it first. You have to see what the key components are, what's the topology of that shape. And we can see here we have these rings, and these rings, if you look closely, they are actually cones. They are cones that are cut. They are not cylinders, because if they were cylinders, they couldn't really, oops, I cannot really zoom on the image, they couldn't touch their faces if they were cylinders. If they were cylinders, they would intersect each other, placed on a sphere like this. Let's see more of the pictures. You can see this is not some kind of a uniform pattern here. There are multiple different sizes. The smaller ones go to the bottom, the bigger ones go to the top, pretty much as what you can imagine happens if you have a jar of stones. Like the small stones would go to the top because they go through all those spaces created by the bigger stones. So this is what's happening here, and they touch, and you can see how it is actually made. This is all made of cardboard, by the way, and it's a really interesting project. It's 10-year-old now, so it's from 2010, which is before Dynamo even existed. But you know what existed there? Grasshopper. And I believe they did it with Grasshopper. It's not the only tool that can do this, but why is it called Pact Pavilion? Because it is packed. Packing is a problem in computational design and programming. So here I have just googled circle packing, and you can see this is exactly the shape that we have here in our pavilion. This is in 2D, of course, but it's pretty much the same shape. So circle packing is a problem of how to fit a certain number of circles with different radii or radiuses. I don't know what's the plural of radius, and you fit them in a shape. It could be a sphere, it could be a circle, and it's a complex problem computationally. Actually, it's been tackled in the recent years. I took some time to read those articles. It's really interesting, really, and I found, like, if we type in circle packing Grasshopper, then we can find some similar things that are made there with plugins for Grasshopper, which is a plugin for Rhino. And it is pretty much like, I'm just opening a random article here. You can see I haven't even opened that until now. The thing is, it's complex math, and it's not even analytical math. It is something that you can achieve with genetic algorithms, or Kangaroo is actually, yeah, let's see that. Kangaroo is a plugin for Grasshopper, which is doing these optimization algorithms. Yeah, that's the character of the sheep. And it's an interesting topic, but we cannot do that in Revit without coding. If someone can do it with Refinery, which I doubt, show me. But Refinery is a tool for optimization with Dynamo in Revit, but I don't think it can do packing. At least I can't think of a way to do it with Refinery. Of course, somebody might have an idea how to do this. And the way to do this automatically in Revit would be to write your own packing algorithm in Python in Dynamo and place those. But what we can do, of course, is we can model this manually with panels and families, like that. And we can change, of course, individual sizes of those, and we can move them in a way so they touch when they need, which is, as you can see, it's a lot of manual work, but you can do it. And because it's a lot of manual work, that's why I haven't really created the whole sphere. But I have only made a few panels, and I really wanted to show you this, guys, because it's an interesting problem. I probably will be tackling this programmatically in the future if I have the time to do this, because being a BIM manager isn't really leaving too much time for fun stuff like that. But this is how you can do it, and let me just put another one and make it bigger. We like it big, don't we? Bam, like this. And we can put it here. So how is this made? Well, in this case, I'm in a project environment, but you can make it in a family as well. And this is a generic model family that I made, and we are actually, this is a face-based model, and all these are based on the face of a mass, which is a sphere. And that's nice, but we have like those individual elements. And what I want to show you now is how to make these to be in the wall category in a project. So kind of good BIM and interesting shape. So what we want to do now, I really like playing with those. I'm going to show you how to do this. I'm going to show you how to make this family, and I hope we are cool. I'm sure that in the comments somebody is going to ask for the family. Can you share the family? And I don't know if I'm going to share the family. Maybe I'm going to sell it to you. I don't know, but I'm going to show you how to do it. So that should be more than enough. And here we go. Now, the problem with this approach right now is that we have just that mass, and we have those individual families here, which is, I call it a problem. It might not really be a problem. If we just want the shape, yeah, it's a valid way of doing this. But of course, I want to do everything I want to do more and more. So what I'm going to do now is I'm going to do another one, and this is going to be a wall in Revit. And we're going to try to host a door on it. I don't know if it's going to work. Let's do it now. And I'm going to the architecture tab first, and I'm going to create a reference plane here, like that. And I'm going to name that reference plane. This is important. I'm going to name it revolve. revolve, not revolver. And then I'm going to go to this view, and where we are now. Now we can see that mass. I'm going to switch off the masses because that looks nice. And I'm going to create a component in place. Now, most of the time, I would advise you not to create components in place. But if I want this shape to be a wall, it has to be a component in place, because if I make it as a family, like placeable family, which should be a nice way to do it, the placeable family cannot be in the walk theory. And I want it for some reason to be in the walk theory. So I'm going to go here, click make it a component in place. I'm going to go down to the categories and select walls. Wall 1 is the perfect name. And now, while I'm here, I'm going to create 2 more reference planes, like that. And I'm going to pin that one and place a dimension, and I'm going to make this a parameter. This is going to be our radius. I'm going to make it an instance. Doesn't really matter. Okay, now that we have our radius parameter, we can of course go and see if it works, but I'm sure it will work. Hopefully. Well, not so sure. Yeah, it works. And I'm going to go and create a revolve. Pick a plane. Now, that's why it was important to name our plane, because I can now select it here by its name, and now I'm on that plane. I'm going to go for the axis line, and I'm going to select my plane here, and I'm going to lock it to that plane. And I'm going to move it up, actually, like that. Then I'm going to go to the boundary line, and I'm going to create a start and radius arc. Or I can also create a center and arc, whichever you prefer. Like that. Perfect. Almost. The thing is, I want this arc to be connected to both of our planes. So I can go here, check center mark visible, and I'm going to align it center to that one here and lock it. And then I'm going to make the radius a parameter, and I'm going to connect it to our radius parameter here. Okay, but now you saw that this moved, and we don't want it to move frivolously. But first I'm going to close the shape like that, and I'm going to get that solid here. Then I'm going to go and create another reference plane like that, and this is going to be my base. I really want to have a reference plane on the base. Now, first thing I'm going to do is I'm going to align it with the level like that. Then I'm going to pin it, and I'm going to go to edit the revolve. Just, you know, it's good to know where the center of your revolve is. So I'm going to align it like this, and I'm going to align that as well. Good. So now we have our parametric sphere, and we're still in that in place model. Now it's a good time to go and create the cone, and I want to show you how to create it from scratch. So it's a phase-based family. So I'm going to go and create a new family like that. And I'm going to select the face-based template. And this is our face-based template. The first thing I want to do is I want to create 4 reference planes. And I want to make them on equal distances from the center, like that. And I want to make these two a parameter. I'm going to name that parameter size, and it's going to be an instance parameter. That's important. Or I can also name this radius. It doesn't really matter. And now we have that nice square thing. And then I'm going to go here to the back view, because I like it from the back. And this is pretty much like a side view that we have. And this reference level here is the face of the plane where we are going to host that element. And since we work with a sphere, we want to know what's the radius of that sphere, right? And that's why I'm going to create a reference plane here. And I'm going to create another parameter, and this one is going to be called radius. And this is going to be a type parameter. This is also important. And actually, to be perfectly clear, I'm going to name it sphere radius. Why is that? That is to be able to make the cones adjacent to each other, so they all will like look at the center of the sphere. This is key actually to make them. Let me show you. You can see how these are able to touch, like they have the same tapering towards the center. This is what I'm creating right now. It depends on the radius of the sphere, right? Okay, let's get back to it. So we have that sphere radius parameter already. Good. Now the other thing I want to do, I want to create another reference plane for the depth of the thickness, in a way, of the cone. And yeah, let's make that parameter, name it depth, like something that is deep, not like something where you owe money to the people. And this is also going to be a type parameter, like that. Great. Now I want to create my tapering, and to do this I'm going to use a reference line. I'm going to connect it from here to here, and to make sure I snap to the intersection, I can press on my keyboard SE, snap intersection, and I want to lock that line to those planes. So I'm going to lock its first point here like this with the align tool, and pressing the padlocks, and also to the middle, center, and to the bottom plane. What that means is that now if this moves, the line will move with it, and that's giving us our cone tapering. And now I want to create another line for the thickness of the cone. And I'm going to set the work plane to the work plane of that reference line. And then I'm going to draw another reference line, like this here. And I'm going to put a dimension between those two and make that a thickness parameter, which is also going to be a type. Okay. Now we are good to create our new revolve. We are using lots of revolves here. So let's go, create a revolve, get the axis line, like this in the middle, and now draw the boundary line. And I'm going to pick the reference level. Then I'm going to pick those two reference lines and that reference plane, and I'm locking all of them. And now this doesn't look like a profile, but I'm going to go and trim those lines like this, and voila, we have our profile. So I can just finish this, create a material parameter just because we like it like that. Let's look at this in the 3D. Looks juicy. Let me save that. Cone 2. And let me load it in the project while I'm still editing the sphere. So since I'm still in the sphere, and I can go here in that 3D, find my sphere, and here you can see we have two options: place on face and place on work plane. Of course we want to place that on face. And here we go. And by the way, this sphere, I'm going to create a visibility parameter because we don't want to see the actual sphere. So sphere visibility. Go make it an instance parameter. I don't know. Good. And now, of course, you see that button here. We have preview visibility off. We can turn it on and see what happens. Of course, it still looks the same because this one is turned on. If we turn it off, we're going to only see our panel. And it looks weird now. Why does it look weird? Because we have to connect its sphere radius parameter to the radius of the sphere. So let's see if we can do this. Okay. Okay, we can't really connect it to that one. Why is that? Because in the in-place component family, to be able to make this, we need to have an instance parameter. So I'm going to go and edit the family, and I'm going to change those. So our sphere radius, I'm going to change it to an instance, and the thickness as well. I'm just changing all of them to instance parameters now. The depth as well, so I can connect it to the parameters of the in-place family. Load it back in, override the existing version. Okay, here we go. Now you can see that I can connect the sphere radius to the radius parameter of the sphere. And you saw how the bottom opening adjusted. And now this is equal to 6000 because our parameter is 6000. Right. Let's turn that off. Let's continue with this. So, to control all of them, I'm just going to create additional parameters like the depth and the size. The size has to say a different thing, but the thickness, I'm also going to connect it to a parameter. Thickness. Okay. And now I'm just going to hit CS to create more of these on our sphere. And we can make them touch. Let's first, like this. And then I can go and pick individual elements and modify their radii or radiuses, whichever you prefer to call them. And I can go and adjust those manually. And I know it's a hideous work to do, but really to make the packing algorithm, this is a complex problem. I'll be looking into it, but just be warned, this is a complex problem. It's not something that you can do quickly on your way home. Let's make that big one here, right? Because the original one had a big one. Okay, so we can move it here and just nudge those around. So that is how to make that shape in Revit without any computation going on. So it's absolutely not optimal to work with those manually, but it is doable. And if we want to do it, we can do it. And we can, of course, continue. The thing is, yes, we can place a bunch of those with Dynamo, or we can place them with divided surface, but then they will not be able to touch like this. They will be just somewhere in the space. They might be uniform or not. And this might be or might not be what we want, but if we want to copy that Pact Pavilion, we have to place them manually like this, or we have to come up with a way to pack them programmatically. I might do a follow-up video on this if I find a good automatic way to do this. I would appreciate your support. If you want to see, like, I want to see it, so I don't care if you appreciate it or not. I wanna make it anyway. So that is basically how to do this. And what I'm really interested to see now is if this can host a door and an actual window when we finish it. And yeah, I want to mention now that these ones that we created, the newly created ones, they don't have their parameters connected to the sphere parameter, so we are going to have to do that manually again. But here it's just a matter of selecting all of those and saying, okay, this is the depth and this is the sphere radius and this is the thickness, like that. Okay, and I'm going to finish the family, and now we have that thing as one family, and it says walls here, which is crazy. And since it says walls, we can try and create a window, and yeah, it took the window. It looks ridiculously, but it still can host a window. And door. Isn't that door adorable? Oh my god, so much cringe. Let's make a new one here. Great, here we even managed to cut a little bit of the geometry. Cool. Well, I think that's cool. What do you think? Did you like that? Tell me in the comments. And see you next time.